This is the National Weather Service Raleigh with a winter Skywarn training presentation designed for the 2024-2025 winter season. First off, which office ends up covering you? There are 100 counties in North Carolina, and those are covered by 7 different offices. 3 of those offices are physically located in North Carolina. The 31 purple counties are covered by us, the Raleigh Weather Service office. There's also an office in Newport, North Carolina, near Morehead City, and one in Wilmington, North Carolina. The counties in the northeastern portion of the state are covered by the Wakefield, Virginia office, northwest by the Roanoke, Virginia office, a lot of the southwest by the Greenville, Spartanburg, South Carolina office, and finally the 2 westernmost counties, Cherokee and Clay, are covered by the Morristown, Tennessee office. There are 122 local offices around the country. So why do we have a winter Skywarn presentation? The National Weather Service's mission is to protect life and property, and winter storms certainly do that. In many locations in our region, winter impacts are relatively rare. We went 2 full winter seasons, I believe, in our forecast area without a single snowflake. Winter impacts are generally broad in nature, while summer impacts are generally more localized if you were to have a particular thunderstorm moving through. So it's important that we end up talking about this. Here's an outline in general of what I will end up going over through the presentation tonight. So let's start off with winter hazards. So what are some of the primary winter hazards that we have in North Carolina? Heavy snow, ice, and cold outbreaks. It's kind of hard for me to show you a picture of a cold outbreak. Certainly a picture of ice. I believe this was from back in 2012 when there was a good freezing rain event, and tree branches are not supposed to be doing that, and the trees themselves aren't supposed to be sagging like that. Over to the right, that is an image from a snowstorm. Actually, that might have been the 2012 storm. This is on Glenwood Avenue, US 70, just to the east of Interstate 540. And so, I mean, it looks like a scene out of a movie with the cars and the one on fire and all the pedestrians and everything. Just not a good situation overall. So snowfall statistics for Raleigh, the record began in 1887. And when we end up looking at a normal seasonal snowfall, that's using a 30-year climatology. And we update this climatology every 10 years. And so that is 5.2 inches. And that has come down in recent years. I believe when I moved to Raleigh in 1993, the average was right around 7 inches. So that would have been a 1961 to 1990 climatology. So with an entirely 30-year different set, that snowfall has come down to 5.2 inches. We'll talk a little bit more about the variations in snowfall coming up. The largest seasonal snowfall on record in Raleigh was 31.6 inches all the way back in the 1892-1893 winter. The largest monthly snowfall we had was 25.8 inches in January 2000, and you can certainly see that that dominates the rest of the numbers for Raleigh. The largest snowstorm itself, the largest one-day snowfall, and the highest snow depth that was measured. One of our other 3 climate sites that I'll end up focusing on is Greensboro. Our 3rd long-term climate site that we do daily statistics for is Fayetteville. However, we do not have an observer recording snow officially at the Fayetteville airport. The normal seasonal snowfall for Greensboro is 7.1 inches, so a little bit more than Raleigh. Their largest seasonal snowfall is 32.5 inches, not in the same year, that was 1926 and 27. Again, that 1927 was the largest snowstorm and the largest one-day snowfall, both in March, actually. And then the largest monthly snowfall was in January of 1966. So I want to take a minute or two to explain the differences in types of precipitation. Sleet and freezing rain, we'll get a little bit more into this later on in the presentation. These are both common precipitation types in North Carolina, specifically because of the Appalachian Mountains. And so a snowflake starts as ice and ends up remaining ice all the way to the surface, an ice crystal. Sleet and freezing rain is determined by the thickness of a warm layer and the thickness of a cold layer. For the sleet, what ends up happening is that snowflake ends up melting to a raindrop in the warm layer, and then the atmosphere is cold enough and it's thick enough near the surface that that raindrop is able to refreeze completely before it reaches the ground. As opposed to the freezing rain, where the below freezing layer is not thick enough to refreeze the raindrop. So it is still rain as it is falling, and once it hits the surface, it freezes on contact itself. So sleet and freezing rain are definitely not interchangeable precipitation types. And here's kind of another way of looking at it. If our x-axis from left to right is taking a look at the temperature, and the y-axis top to bottom is taking a look at height. You can see that with the snow, if the green line, green dashed line is the trace of the atmosphere, that the entire atmosphere is below freezing. So the precipitation is snow the entire time. With sleet, there is a shallow warm layer that's at least deep enough to melt the snowflakes into raindrops, but then the precipitation particles refreeze into ice pellets before they end up reaching the ground. Again, freezing rain is a more shallow cold layer, so the precipitation is rain in a liquid form all the way until it reaches the surface. And then this is something that the Maryland Office of Preparedness and Response ended up sending out 1 or 2 winters ago, which I think is a fantastic way to visualize sleet versus freezing rain. So the sleet is sugar that has fallen onto the donut in a solid form, as opposed to the glaze with the freezing rain, where the sugar that was falling onto the donut was in a liquid form as it fell, and then it froze onto the surface. So this is just the best way that I've ended up seeing to visualize the difference between sleet and freezing rain. Some cold temperature statistics for Raleigh. The coldest low temperature was 9 below on January 21st, 1985. And the high temperature that day was 7 degrees. The coldest daily high temperature that we've ever had in Raleigh happened all the way back in 1899, and the high was 10 degrees. The low was 4 degrees that day. So a relatively small window of temperatures. If we look at Greensboro, hey, January 21st, 1985 again, 8 degrees below. So they were actually not as cold as Raleigh ended up being. And they got all the way up to 21 degrees that day. The coldest high temperature in Greensboro, again, many years ago, 13 degrees, and they had lows in the single digits. And finally, Fayetteville, once again, January 21st, 1985, they had that low temperature 2 days in a row, but they got much warmer on those days. And then again, the coldest high temperature that Fayetteville has had was 18 degrees back in 1917. We've had a lot of warm spells in Raleigh recently. I'm not going to read the text for all of these slides out to you, but I've included numbers from November, December, January, February, and March. So just kind of for the first 2 bullets, in 2020, Raleigh was tied for the 3rd warmest November. The average temperature, taking all of the daily highs, daily lows, and averaging those all together, came up with a number of 55.8 degrees. For comparison, a normal temperature for the month of November, the normal monthly temperature is 51.5 degrees. The record warmest was 58.3 degrees, set twice. The lowest, record lowest was 42.5 degrees back in 1976. So again, you can see that to get the record, that there's about an 8-degree window kind of on average. Again, we have the 3rd warmest December on record in 2021. Earlier this year, back on January 25th, 24, we tied for the warmest daily January low temperature. The coldest we got that day, I don't have it in front of me how warm we ended up getting. The low was only 64 degrees that day. Taking a look at February and March, it was back in February of 2023 that we had the warmest temperature that we've ever had in the month of February in Raleigh, and that was 85 degrees. It was also the warmest month, warmest February on record. Again, back in 2020, the warmest daily March low temperature, the temperature only fell to 69 degrees on March 29th. And again, I don't have what the high temperature was in front of me. We take a look at Greensboro, not as many recent warm spells, but there was the 2nd warmest December on record in 2021. And then again, tied for the warmest daily February high temperature, February 23rd of 2024. And finally, as I move on to Fayetteville, it was a warm November of 2020, a warm December of 2021. Again, February 23rd, big day across the area. Warmest daily monthly high, and again, a warm March of 2020 as well. Again, I won't end up reading all of these statistics off to you. They are all available as you're taking a look at this in the video later on. When it comes to daily cold temperatures, let me kind of explain all the different lines that I end up having. If you look at the average daily high, and you end up looking at what is the coldest day at each one of our 3 climate sites, the coldest average daily high is 49 degrees in Greensboro. It's 52 in Raleigh, it's 54 in Fayetteville. All those averages are 1991 to 2020. Then what I did in that second row is I showed you what the coldest daily high was each year. So on average, it might be 49 in the Greensboro area. But when it comes to what's actually observed each year, we typically end up having a day where we won't end up getting to much more than freezing or even to reach freezing. Over the last 30 years, that's what the average has been. Similarly, if we look at the coldest average daily low, you can see that that average is somewhere around freezing for each of our sites. But again, in any given year, we will likely end up going somewhere between 10 and 15 degrees for a single day. Now, if you look at what actually occurred on December 24th, 2022, that was the coldest that it had been in some time. And I can't remember which site is which, but for one of them, reaching that low temperature was the coldest day in 5 years. For one of them, it was 10 years. And for one of them, it was 20 years for how cold we ended up getting. All right, moving on to a snow climatology. So many of the graphics I will be showing tonight come from the North Carolina State Climate Office. This is the normal annual snowfall from 1991 to 2020. And again, it's a broad scale climatology. It does not include smaller areas with slightly higher or slightly lower snowfalls. Again, you can see that 4 to 6 inches covering most of Wake County. And then as you get over by Greensboro, kind of in that 6 to 8 inch stripe, and some of the highest peaks in the mountains receiving more than 2 feet of snow each year. This is a snow climatology that was put together by Eric Webb. It's Weber Weather on Twitter or X. This goes from 1948 to 2021, and many data sources that you can see at the bottom, and showing kind of when we would expect to see particular amounts of snow. So what is that? Chance of a winter storm on a given day. Our peak for any sort of snow, well, I shouldn't say any sort of snow, at least 1 inch of snow or a trace of freezing rain is during late January. But interestingly enough, if you were to take a look at that next bluish green color, at least 4 inches of snow or 1/4 inch of freezing rain, that actually peaks kind of in the first half of February for the most part. And that's the same for what he has labeled the extreme and historic amounts. You can see it's very hard to end up receiving any snow or freezing rain after April 1st. Now, when it comes to a ratio of snow to liquid, pretty much everybody talks about a rule of thumb being that you would have 10 inches of snow for each 1 inch of water. And so as part of a national study that was done, that odd shape that you see to the right is actually showing our 31 county forecast area. And it says that across the area, when they did this 30-year climatology, that the average snow to liquid ratio around here was 9.6. And then at the bottom is showing the number of frequency of observations. And even though 10 to 1 was measured the most often locally, you can certainly see that there are many times that that ratio is not true. So if you end up looking at something lower than 10 to 1, that means if you were to have 5 inches of snow for 1 inch of water, that's going to be a very wet and heavy snow, because again, there's going to be a lot more water in that snowfall, as opposed to if you go to something higher where you might have 20 inches of snow with 1 inch of water, that's going to be a much lighter, a much fluffier snow, a lighter consistency. A lot of times lake effect snow would end up being of these higher snow to liquid ratios where the flakes are more fluffy overall. And this is a similar map, and again, you can end up seeing that in the Rocky Mountains. You can see the Appalachian Mountains showing up a little bit, but especially around the Great Lakes themselves, you can end up seeing those higher snow to liquid ratios going on. And then a lot of the South, there simply wasn't enough data to accurately represent what these average snow to liquid ratios would be. So again, taking a look at the snowfall statistics for the 2 out of our 3 climate sites where we do have an observer and we do have reliable data. As I said earlier, Raleigh averages 5.2 inches of snow and Greensboro is 7.1 inches. You can see how those numbers break down for each month at the individual sites. Again, some more images from the State Climate Office. They update these typically once a year. So this image was produced this previous summer. So I do know that there were a couple places that ended up getting an inch of snow last week. That is not represented in the map since the map hasn't been updated since then. But the colors are showing approximately when that ended up happening. So much of the state had its last 1 inch or greater snow event in the winter of 2022. You can end up seeing with the darker blues or purples that a lot of the mountains ended up having a snowfall earlier this year. As you end up going towards the coast, you can end up seeing that for a lot of those areas, it was 2017 to 2019. The extreme southeastern tip of North Carolina, it's been, 13, almost 14 years since they ended up having a 1 inch snow event. Now let's jump ahead to a 6 inch snow event. And again, the blue, most of those are going to be somewhere in the last 5 years. For much of our forecast area, again, in the central portion of the state, a lot of areas it was December of 2018. There are also many areas where it was December 25th and 26th of 2010. If you go to the southern part of the state, again, you're looking all the way back to 1989 to end up having a 6 inch snow event. And then finally, if we're looking at the 12 inch snow event, there's a very little portion of eastern North Carolina by the Outer Banks that may have never received 12 inches of snow. The State Climate Office was not able to determine when that ended up occurring. For much of our area, it ended up being either the January 2000 snowstorm or the January 2002 snowstorm. Although, as you can see, certainly other places have had storms more or less recently. This is another graphic put together by Eric Webb, where he ended up taking a look at the freezing rain events per year. And again, many data sources listed there, including the North Carolina State Climate Office, our past events website, and several other locations. And so you can see that actually the triad is kind of the most likely place to end up experiencing freezing rain in a given year over this 30-year climatology. And later on in the presentation, I will go a little bit more into the mechanics of why that is a favored location for us to end up seeing freezing rain out in that direction. There's a lot going on this plot. I have one for Raleigh and one for Greensboro. So let me explain what's going on here. These records go, as I said, the snow records go back to 1887 in Raleigh. And so the blue line is showing the yearly snowfall that ended up occurring every year. Now, I mentioned earlier that the 5.2 inches is the climatology between 1991 and 2020. That is the yellow dashed line that I have going all the way across. But if you were to take a running 30-year average or a running 10-year average, those are the green and red lines that I have on the plot. So you can see that if you were doing a 30-year running total, looking at 1920, that was closer to 10 inches. And then you can see it's kind of slowly come down, particularly over the last 30 to 40 years. And that's how we have the current 5.2 inches. In the upper right, I've listed the 5 snowiest seasons on record in Raleigh. But one other thing that I want to point out, I said in the bottom right, 16 years within 2 inches of climatology. We describe a climatology as what we might expect, what's kind of normal. But I want to point out that these records go all the way back to 1887, and that, 137 years. We've only had 16 years that were within 2 inches of climatology, and I'm using that 5.2 inch number as a static number. But you can see we've had many, many years that we've had over 10 inches of snow. We've had many years that we haven't had any snow, including the last 2 years. So around here, using climatology it's an average over the 30 years, but that doesn't mean that we should expect to end up seeing that number every year. In fact, gosh, only about 10% of the time have we ended up actually having a number within 2 inches of that. So if I were to take all of the numbers from all of those years of snow, 0.6 inches, 2.3 inches, and if I just got rid of whatever the 10th place is, and I kept whatever the number is to the left of the decimal point, that's what this plot is showing. And so in that sense, that actually says that the most common amount of snow that we have, if we were to put it into 1 inch bins, is actually 0 to 1 inches of snow. That happens the most frequently, with the next most frequent amount of snow being somewhere between 2 and 3 inches. There were 23 seasons that we had more than, that should read 12, more than 12 inches of snowfall. So again, even if 5 inches is the climatology number, that doesn't mean that we should expect to end up seeing 5 inches of snow every year. This is a very similar plot for Greensboro as opposed to the Raleigh. So again, you have the running record in blue for every year. That 1991 to 2020 climatology is a yellow dashed line going across. The 5 snowiest years in the upper right. And in Greensboro is 21 years have been within 2 inches of climatology. But you can still see how up and down these numbers are, that we aren't seeing numbers right around 7 inches very frequently. And again, taking a look at the integer amount of snowfall at Greensboro, this is even more noticeable than the Raleigh numbers, in the fact that the 0 inch really stands out here, saying that there have been 25 years that there was less than 1 inch of snow for the entire season at Greensboro. Interestingly, the next highest amount of snow that occurred was 8 to 9 inches. And in this plot, there were 18 seasons that had at least 15 inches of snow. So again, interesting to see, even if we have an average amount, we're not seeing average totals most of the time. All right, I want to move on to some of the products that we end up issuing. So we have 3 levels of notification. We have a hazardous weather outlook, watches, and warnings. So hazardous weather is something that is used to generally discuss storms and events several days in advance to alert the public for the potential of an event and allow for early planning and preparations. And kind of a ballpark is that we are normally issuing these with approximately 30% confidence that will reach our warning criteria anytime during the upcoming 7 days. And I will end up going over what the criteria are for the different winter products later on. A watch is issued when we have heightened potential of warning criteria, whether that's a winter storm, a blizzard, a wind chill. I put wind chill, I need to fix that. That is issued when we have about 50% confidence that we're going to end up reaching our warning criteria. And finally, a warning is issued when there's a high probability of warning criteria or the warning criteria is already occurring. And we are supposed to issue this when we have approximately 80% confidence that we will reach warning criteria. And we also issue advisories, and those are issued when there's a high probability of an event that will produce conditions which are a nuisance, but not necessarily life-threatening. And those are also issued with 80% confidence of the advisory criteria. But I want to warn you, do not think of a watch going to an advisory as a downgrade. Although the warning criteria is higher than the advisory criteria, the issuance of an advisory still means we have high confidence that there are going to be important impacts, because watches are issued with 50% confidence in something occurring, and advisories are issued with 80% confidence in something happening. Marshall Shepard, a former president of the American Meteorological Society, ended up getting this example from Brad Panovich, one of the chief meteorologists down in the Charlotte television market. And kind of how I showed you that sleet versus freezing rain image earlier with the sprinkles versus glaze on a donut. The watch means that we have the ingredients for something to come together. In this case, a cupcake. We have the necessary ingredients, and if they come together in the right formation, we could end up with a cupcake. But we just have the ingredients so far. The cupcake warning says that a cupcake is imminent or is already occurring. So again, the watch means that we have the ingredients for something to come together. The warning means it has actually come together. Again, showing the definitions of a winter storm watch, a winter storm warning, and a winter weather advisory on a single slide. Again, I will not read the slide to you, but again, a watch is telling you to prepare that something could be coming together. A warning is high confidence in something that will threaten life and property. An advisory is a high threat of a lesser amount. All right, so let's define some of our other products other than watches and advisories and warnings. So winter storm warning, there are local criteria. All of the offices across the country have their own criteria. There's not a single criteria that every office ends up using. For the Raleigh forecast area, we will issue a winter storm warning if we expect to have 3 inches of snow in 12 hours or 4 inches of snow in 12 hours. A winter storm warning for ice is issued when at least 1/4 of an inch of ice is expected in a storm total. And a winter storm watch would be issued when we have a 50% potential for the winter storm warning criteria in the future, whether that's either expecting the possibility of the 1/4 inch of ice or the 3 or 4 inches of snow. And again, for ice, I should be specific, this is for freezing rain. This is not for an amount of sleet. We very rarely have long-term sleet events. Winter weather advisory for snow is issued if we have 1 inch of snow in 12 hours or a mix of accumulating snow and ice. Kind of along those lines, if we're expecting any ice, if we're expecting any freezing rain, we are supposed to issue a winter weather advisory because it doesn't take much freezing rain at all to accumulate on any surface for that to be hazardous. So if we are expecting any freezing rain, then we will end up issuing a winter weather advisory for that. So taking a look off of the IEM website, it's a website run by a group up in Iowa. This is taking a look, and I recently generated these images last week, showing a yearly average over the last 20 years of how often we end up issuing advisories and warnings for each of our counties. Because in our area, we are issuing winter weather advisories and winter storm warnings by counties, as opposed to something like a severe thunderstorm warning or a tornado warning. And those are boxes that can cover portions of counties. But when we issue a winter weather advisory or a winter storm warning, it's in effect for the entire county. So I'm sure it's of no surprise to you that the farther north and west you get, where it's a little bit colder, is where we typically end up having more of the advisories or more of the warnings. I also wanted to zoom out. The color scale is going to be a little bit different because this is now including what ends up occurring in the mountains as well. So those numbers should be generally the same for our local area, but I wanted to show you that it's much more frequent in the mountains that these products are being issued and much more rare along the coast. If down in the southeastern portion of North Carolina, it says that there is an average of 1 warning issued every 6 years for those counties. I have wind chill warning and advisory crossed out. We'll come back to that in a second. A high wind warning is issued. It's very rare that we will issue these for sustained winds of at least 40 miles an hour for 40 miles per hour for at least an hour. Much more frequently, we issue a high wind warning when we expect to have a gust of at least 58 miles an hour. And that might seem like a kind of arbitrary number. 58 miles an hour is equal to 50 knots, which is 50 nautical miles per hour. So in one system of measurement, that is a round number of 50. Again, in wind advisory, we very rarely have sustained winds of at least 30 miles an hour for at least an hour. Much more frequently, that's when we have a gust of at least 45 miles an hour. And if the 58 miles an hour number sounds familiar to you for somewhere else, that is the criteria that we end up using for severe thunderstorm warning. So severe thunderstorm warning is for any gust of at least 58 miles an hour. A high wind warning is when we're expecting that on a broader scale to have a gust of at least 58 miles an hour. So wind chill, let me explain the concept of wind chill, what's going on. When there's no wind, you have your average body temperature, and your body radiates heat outward, but it kind of forms kind of a cushion, kind of a layer around you that insulates you from the cold that is going on around you. However, if it's windy, what ends up happening is that wind is going to blow away that layer of warmth away from you. And so in that sense, that warm layer that you have around you that your body is radiating out, the wind will end up pushing that away. And so that speeds up heat loss. The Weather Service has made a change this year. We are no longer issuing wind chill advisories and wind chill warnings. We've ended up moving to cold weather advisories and extreme cold warnings. And the primary reason for that is because of the fact that even if it's really, really cold, even if there isn't wind, there can still end up being danger with that. So this change to a cold weather advisory and an extreme cold warning, this is something that is happening across the United States with the Weather Service as a whole. That is not a change to our local office here in Raleigh. And so I didn't put in text what those numbers are. We just ended up using the maps here. So for a good portion of our forecast area, if I should read the top again, cold weather products are based on apparent temperature, also known as wind chill. They do no longer have a wind requirement. In the past, we were required to have at least a 5 mile an hour wind. So now if we were to forecast a temperature of 3 degrees in Wake County, but it was calm, that would still meet our cold weather advisory. Certainly if we have, I'm just gonna make up some numbers, if we had a 10-degree temperature in Wake County and the wind was gonna be 30 miles an hour, that would drop the wind chill below 5 degrees Fahrenheit, which would also prompt a cold weather advisory. So again, this change is being made nationwide. And so you can see that those numbers are based on a climatology of how frequently these values occur in the areas. Blizzard warnings. According to the National Weather Service definition, a blizzard warning has 3 criteria. You're required to have frequent gusts to 35 miles an hour or more. You're required to have snow, whether it's falling or blowing, that reduces the visibility to a quarter mile or less. And both of those, the wind and the snow visibility, needs to last for at least 3 hours. It's quite rare for the visibility to remain less than a quarter of a mile for at least 3 hours or more. And blizzard warnings are not dependent on snowfall accumulation. The Raleigh office has never issued a blizzard warning. Now, I'm not saying that people wouldn't end up describing something as being like, oh my gosh, we had an inch or 2 of snow and the wind was blowing 50 miles an hour. But if it only happened over an hour or 2, that doesn't meet the National Weather Service criteria of a blizzard warning. So in that sense, we're a little bit different. Interestingly enough, I previously worked at the Pittsburgh, Pennsylvania office, and I did end up issuing a blizzard warning when Hurricane Sandy ended up making its way across New Jersey and Pennsylvania. And they had blizzard conditions for nearly a day in the northern West Virginia mountains. They had 35 mile an hour snow, 35 mile an hour wind. They had the quarter of a mile visibility or less, and in some places it lasted up to a full day. They also had 2 to 3 feet of snow in some places. But at this point, the Raleigh office has never issued a blizzard warning. All right, moving on to some miscellaneous items before I get into snow and ice forecasts. So some major types of systems for wintry precipitation across our forecast area are an Alberta clipper, a nor'easter, and cold air damming. So an Alberta clipper is named for the Canadian province. Since the system develops over land, there's limited moisture that might result in only light snowfall, even if there's a lot of coverage of that snow. So again, that's just kind of showing the track of a low pressure system moving from the province of Alberta over the Great Lakes, moving over the mid-Atlantic, and then it would end up bringing much colder air behind it. And again, this is just another graphic showing this. A nor'easter kind of has two different reasons for its name. One is the fact that they typically move up the east coast of the United States, so they are moving towards the northeast. Also, there are northeast winds experienced on the leading edge of the storm. So many of these nor'easters pass east of our forecast area, but not all of them. For anybody who remembers back to March of 1993, there was a low pressure system that was developing over the western Gulf of Mexico Friday morning. It was moving up over Georgia Saturday morning and up towards New York City Saturday evening. And that ended up producing a lot of snow along much of the East Coast and actually ended up producing thunderstorms and some tornadoes that ended up resulting in some deaths across Florida as that storm ended up moving through. And again, another image from weather.com describing some stuff about nor'easters. Finally, cold air damming is not something that's localized just to North Carolina, but it can end up causing its own set of problems here. So what this, it's kind of hard to show this three-dimensionally, but what is going on in this case is, imagine that those are the Appalachian Mountains and we're on the east side, we're kind of looking up to the north and west. What can end up happening is if you end up having cold air that's funneled along the mountains, in our case, that would be moving from northeast to southwest along the eastern spine of the Appalachian Mountains. If you have warm air, we talk about warm air rising, and if the warm air is able to rise up and over the cold air, then we can end up having a situation where we're going to have cold air a couple miles up in the atmosphere, then we have a layer of warm air, and then we have cold air at the surface. And as we discussed earlier, that's going to be a prime recipe for end up having sleet and freezing rain. So the fact that many times we have this push of cold air toward near the surface and then warm air rising up and over it, that's the reason that so frequently we end up having sleet and freezing rain as opposed to just snow in the Carolinas. So again, I know I already ended up showing you this graphic earlier, just kind of wanted to bring it back to end up showing you again. One of the difficulties when it comes to forecasting cold air damming events is that cold air is pushed against the mountains, and because it is cold and dense, it is not able to rise up over the mountains. And so the warm air goes over the cold air. And so one of the most difficult things for us is forecasting how thick the cold layer is going to be at the surface and how thick the warm layer is going to be aloft. And so that can end up making a huge difference in what our precipitation type is. So I want to stress to you that that's the reason that sometimes we have difficulties when it comes to predicting exactly what the precipitation type will end up being, even if these lines end up shifting by 10 or 20 miles. That can move an entire forecast, west or east by a county, and everybody's precipitation types can end up changing. So again, a way to visualize this, the difficulty is determining what the thickness is of both that warm air and that cold air. And so those vertical lines showing the snow to mix line and rain to mix line, the distance can vary. Sometimes we don't end up having a mix. It might just be snow and rain. But again, this example is just showing that the difficulty that we end up having on the eastern side of the Appalachian Mountains when it comes to determining what those precipitation types will be. One that we frequently end up hearing is people say, oh, there was lightning and everything, so that means that we're bound to have snow in the next 7 to 10 days. Well, this is from a blog entry that Corey Davis at the North Carolina State Climate Office did back in December of 2013. And he collected all of the lightning reports in December, January, February, March at 6 places across the state: Asheville, Charlotte, Greensboro, Raleigh, Wilmington, and Hatteras. And he found 642 days where thunderstorms occurred, but it was only 13% of the time that snow is observed, not even in the next 7 days, in the next 10 days. So a lot of times people say, oh, there was lightning, that means we're going to have snow. He has worked the numbers, and I don't know that he's going to go back and revisit this, but again, looking across North Carolina as a whole, it is pretty rare that we end up having snow anytime immediately after we have a thunderstorm. I wanted to show you the official winter outlook. This was released on October 17th in 2024. And so you can end up seeing that, it's kind of split across portions of North Carolina, but most of the East Coast is forecast to be above normal in temperatures. This is not necessarily saying anything about the magnitude, how great above normal the temperatures will be. Just the color coding is showing the confidence in it occurring. So you can end up seeing that the seasonal outlook was for above normal temperatures across North Carolina and below normal precipitation across the state. And this is for December, January, and February, which is what we consider to be meteorological winter. So for us, we describe meteorological winter as December, January, February, spring as March, April, May, summer as June, July, August, and fall as September, October, November. So this is updated once a month. So this was officially released back on October 17th. Well, has been updated since then? Yes. I don't know why the rule is that they always update it on the third Thursday of every month. But if I go to the next slide, you're not going to see that much of a difference between the October forecasts and the November forecasts. If I toggle back and forth a couple times, you'll see that really didn't end up changing at all across North Carolina. It's not to say that it didn't in other places across the country, but with the update in the middle of November, it is still looking like, according to the Climate Prediction Center, an above normal temperatures and below normal precipitation. Snowfall measuring. There are several steps to giving us a good measurement. A lot of times we request that people have a white board. We realize that not everybody's going to end up going to the trouble of doing that to measuring snow, but it's important to measure snow on a reflective surface so that it is not absorbing heat from the sun, because that would end up melting the snow. So white is going to be reflective. You want to find an open area that's away from tall objects, but also sheltered from the wind. You don't have to go to the trouble of having this flag. Again, this is a generic National Weather Service graphic. Now, it's not to say that if you were up by the Great Lakes that you might not want to have a flag so that you would be able to find where your snowboard is. But it's normally good to measure once a day, again, for people who are frequently doing this, and to measure to 1/10 of an inch. And we can take your reports on Facebook and Twitter and other ways, and I will get into the different ways that you can give us reports a little bit later on. Oops. Measuring ice. Depends on whether you're measuring flat ice or radial ice. And so you need to tell us what your measurement is, if it's flat ice or radial ice, because I can't remember which way the ratio goes, but I think it's radial ice on a branch. That number is about 40% of what a flat ice measurement would be. So I know we have those criteria here in the office that we can end up doing the conversion. So either find a flat surface, like if you were to look at ice that had accumulated on your picnic table outside, that would be a flat ice measurement, or on the ground or on your car, as opposed to the radial ice measurement, which would end up being on a tree branch, for example. All right, I want to go a little bit into snow and ice forecasts themselves. Before I show you any graphics, I want to end up saying that I took screenshots of all these graphics yesterday. So these are not up to date. Where can you find our snow and ice forecasts? If you go to our homepage, weather.gov/Raleigh, and you add /winter, you can get to the page. You can also end up going to our homepage, and under our watch, warning, and advisory map, if you scroll down a screen worth, you'll see a whole bunch of icons, and you'll see that we have a winter weather icon that I put a red box around. During the summertime, this is where we end up having our tropical weather. So that seasonally, this flips back and forth between winter weather and tropical weather. All the rest of those icons should be the same year round. So if you were to take a look at this winter page, this is what the top of the web page would end up looking like. And so we are currently looking, there are several tabs that you can click on. That green one that's highlighted it defaults to a probabilistic snowfall forecast. So if you take a look at that large map that says expected snowfall, official National Weather Service forecast, I took this screenshot, and the information was valid as of 7:17 p.m. last night, Monday night. And this was the official Weather Service forecast. So you can see kind of that lightest blue is to the west and north of Mount Airy. That was an official forecast that the Weather Service had issued as to where snowfall was expected. Now, if you look in the upper right-hand corner, that's the high-end amount, and that's saying that there's a 1 in 10 chance that that amount of snow would end up occurring. And some of that does end up getting into our forecast area. That map is entirely computer generated. There is no human input into creating that map. It's taking a look at a collection of computer models and is trying to end up figuring out what will end up going on, kind of what the most extreme forecast would be. That's kind of the worst case scenario that we're expecting. Meanwhile, in the lower right-hand corner, that's the low end scenario. And there's at least a 90% chance that there will be more snowfall than this. You can see that nothing is highlighted, that it's a gray background. And so in this case, that means that the low end amount is there won't be any snow. So again, that expected snowfall graphic, that is a human forecast that has been put together by us and our neighboring offices. The two images on the right-hand side, completely computer generated, no human input goes into making those graphics. And so I decided to just, sorry, I should have clicked on this, kind of blow it up as opposed to showing you the page as a whole with the tabs. Again, so we can end up zooming in, so you can end up seeing, again, as of 24 hours ago, the higher end potential did end up showing at least 1/10 of an inch into portions of the triad. Now, if you end up clicking, if you end up going down a screen from what I was showing you, if you scroll down on the website, these are percent chances that the snow amounts will be greater than whatever it is. And it defaults to the percent chance of 1/10 of an inch of snowfall or more. And we consider that to be measurable snowfall. Anything less than 1/10 of an inch, we consider to be a trace of snowfall. So again, as of 24 hours ago, again, all of these percent chance graphics, all computer generated, no human input into creating this. As of 24 hours ago, it was showing a 17% chance of at least 1/10 of an inch of snow in Winston-Salem, a 5% chance in Roxborough itself. So pretty contained. These chances would end up being as the precipitation ends up coming to an end tomorrow. We're expecting 1 to 2 inches of rain, could be a chance for some severe weather closer to the coast. Sometimes the models like to end up having a chance of precipitation ending as snowfall. A lot of times this is slightly overdone by the models. A lot of times the colder air takes its time coming in, so the precipitation comes to an end, then the colder air arrives, and the models don't always have a good handle on this. So I would end up saying that this is likely a little bit overdone in this scenario. If you continue scrolling down on that page, you can see snowfall totals by location, and I've taken a screenshot of just the A towns that are listed here. So again, the low end amount, expected amount, high end amount, 0 for all these cases, but you could see that at Asheboro, there was a 10% chance of having measurable snowfall. There are dozens, hundreds of towns listed in the chart. Again, I only ended up grabbing the ones that begin with an A. So there are hundreds of places that you could end up looking at to see what these numbers are. I also wanted to show you, if I end up going back here, so this was probabilistic snowfall forecast, the screen tab. If you were to click on the tab next to it, the North Carolina probabilistic snowfall forecasts, you would end up getting these graphics, the exact same information as what we were looking at zoomed in before, but this is showing a greater area. So it's showing all of North Carolina plus some surrounding area. So you can see that all the way up in Beckley, West Virginia, again, as of 24 hours ago, there was at least a 65% chance, and I grabbed the 1-inch snowfall graphic and the 4-inch snowfall graphic. But these graphics all come in 1/10 of an inch, 1 inch, 2 inch, 4 inch, and there are several amounts. And again, want to continue emphasizing, these percent chance of snowfall graphics are all computer generated. These are not generated by humans themselves. All right, finally, what is it that we would want to have you report to us? When you report weather, be sure to give us your location, including your county. There are several towns with the same name across different counties, and the time that you had your observation. If you're reporting snowfall, we want to know the total amount of snowfall. If you're reporting freezing, drizzle, or rain, there are several different things that we would want to know. First, any occurrence, because as I said earlier, if there's any freezing rain, we need to issue a winter weather advisory. We'd want to know if you reach at least 1/4 of an inch of ice accumulation, because in that case, we should end up having a winter storm warning out. And then also what your total ice accumulation is. And again, remember, we need you to state whether it's a flat or a radial measurement, because those numbers can be very different. If you want to let us know about thunder or lightning associated with snow, sleet, or freezing rain, feel free to do that. That doesn't mean we're going to issue an advisory or warning, but it means that the atmosphere is pretty dynamic if we're managing to have that happen. And wind speeds of at least 40 miles an hour, only if that's measured. Many people, including myself and other forecasters that I know, I think everybody just looking at the tree branches overestimates how strong the winds are and everything. So if you have a measured wind speed of at least 40 miles an hour, we'd love to hear about it. What are some different ways that you can submit a report? You can email us at nws.raleigh@noaa.gov. You can go on Facebook. You can go on Twitter. You can end up giving us your reports that way. We do have a phone number that you can end up calling, 919-326-1040. You can speak to a forecaster 24 hours a day, 7 days a week. Please do not give this phone number to other people. If you want to give a phone number out to people, you can give them 326-1052. But the 1040 number is very specifically for people who have taken Skywarn training classes and are calling to give us reports. Please don't call this number and ask for a forecast. You can end up using the 1052 number to end up receiving a forecast. And remember, even though it's rare, we can still have summer severe weather during the winter season as well. Like I said, we're outlooked for the chance for some severe weather tomorrow. So all the rules for those reports apply as well. I have some information for the Central Carolina Skywarn. They are one of 2 National Weather Service designated Skywarn programs to serve the National Weather Service Raleigh office. Spotters with a ham radio license can make reports via the Central Carolina Skywarn net. Their primary repeater, their backup repeater, the UHF link system, all of those are listed there. Virginia Enzor is the emergency coordinator, and I'd be surprised if she's not on this call right now taking a listen to this. We just ended up celebrating Skywarn Recognition Day earlier this week. They do have a Skywarn Facebook page as well. There's also a weekly practice net that ends up going on. Let's see, it is a Tuesday, right? You're talking to a shift worker. I never remember what day it is. So that'll be going on the on their repeater coming up in a little bit over an hour. There's also a triad Skywarn program as well, and you can see the counties that they end up covering. Some of the counties that they end up covering along the Virginia-North Carolina border are specifically covered by the Blacksburg, Virginia office and not our office. But again, people can end up making reports via the Triad Skywarn net as well. And you can find information on that Triad Skywarn blogspot webpage. You can participate in CocoRAS, which is the Community Collaborative Rain, Hail, and Snow Network. This was originally created out in the Boulder and Denver, Colorado area a little more than 20 years ago because they wanted to get a high density set of measurements for what the snowfall was there. And so this program has spread nationwide. You can learn more about it at cocoras.org. Again, that's for CO community, CO collaborative, RA is rain, H hail, and S is snow. And you can end up getting a rain gauge, a ruler. You can end up using an app or a website and end up reporting your amounts to them, and they send them to us. CocoRAS is not officially part of the National Weather Service. They are their own nonprofit organization, but they certainly share their information with us. There's also MPING, which stands for Meteorological Phenomenon Identification Near the Ground. And you can let us know what precipitation type is happening at your location. This is an old screenshot that I have from when I was at the Pittsburgh office. And so it's an app that's free that you can download via iTunes and Google Play. And so it just ends up asking for your location. It automatically uses that, figuring out your GPS, and then you can go in there and you can see in the bottom left, fog, hail, drizzle, rain, freezing rain, snow. There are all different kinds of weather types that you can end up reporting to us on there.